Now, after our presentation, let's make a live demo for tilted vessel, and let's create a drawing for it. After that, if we have a time, we can make a tube bundle assembly for tube bundle only for AES heat exchanger. So we will have a floating head and tube bundle, some tubes and baffles, and how we can make the arrangement of tubes. But let's, at the beginning, make the first demo for the horizontal pressure vessel. And from here, we will start a new project, and let's define our project as demo. Define the name of the project. Okay, after that, let's select the location. So let's select the desktop, and from here you can select between many different modules, like the horizontal pressure vessel. If you will start creating your pressure vessel as a horizontal vessel, vertical pressure vessel, heat exchanger, a duct, a storage tank with fixed roof, spherical tanks, or piping. Okay, so let's select the overall module to give us the ability to make different types of all features of SEG, like the tube sheet and roof plate, duct features and spherical tank features, all of that. So let's click on finish. And now SEG will start creating the project files on the locations that we defined, which is on the desktop. Okay, and from here you can figure that that is the SEG tree. And when we select the first node, which is the project node, you can define the project information, which we discussed in one of our slides. Project name, project location. After that, you can save that. Some of those information will be reflected to your title block. And from here, for the equipment itself, if we select the equipment, you can define the design data of the equipment if you would like to double click and modify, or import from an external Excel sheet, or remove what you don't like to export and keep the data that you would like to export. After that, you will click on save. The second important point for the equipment, which is the equipment setting. From here, you can select or define the position of the equipment. You have three options: the horizontal, tilted, and vertical vessel. So let's select the tilted vessel and start our arrangement from the left to right. Let's define the sloped or tilted angle as a 1 degree. And from here, let's define the platings and the plate widths. And from here, the units, let's select it as a millimeter. Define the service of the equipment. Okay, and the serial number, like that, and click on save. Okay, one more option for the app setting. Let's discuss it. For the rendering of the elements, if you would like to make a rendering for elements during creation, you will need to select the parent preview to make a preview or rendering for the parent elements like head, shell, cone during creation. And the same for childs like nozzles, the saddles, which they are the attachments for the parent elements. So you will make a preview for elements during creation. And here the size, there are some options here. One of them is the nozzle size. If you would like to make the definition of nozzle in NBS, you will keep this checkbox not checked. And if you would like to make it in DIN, you will select this checkbox to make the format of nozzles in DIN. Okay, now let's click on save. And from the equipment itself, let's add first head, which is left head. Okay, and for the left head, let's discuss the types here on the SEG list. We have more than 17 types of the types of heads, like the ellipsoidal head as a half of ellipse, or the ellipsoidal head with crown and knuckle radius. And here you can figure out with the red color font here the value of the crown and the knuckle radius for this type of ellipsoidal head, flat dashed head, which include knuckle and crown radius, and that's the crown radius value based on the code. Many different types like standard cab, diffused head, and you can check the image on the right hand side. Convex head, flat head, hemispherical head with straight flange, hemispherical head with negative straight flange, which usually used in division 2, conical head with neck at the end, a conical head with closed end, many different types. So let's select the ellipsoid head type and define the inside diameter of this head to be 2 meters and half. The thickness, let's make it 20 millimeters, and for straight flange we will make it 50, and the minimum thickness after forming, let's make it 18, the ratio here, and let's click save. Now if we click on the assembly, automatically SEG will send a command to Autodesk Inventor to start creating the lift head, okay, and assemble it to the final assembly of the equipment. Now let's discuss another option on the same head itself. In each head of those, you will find an option here for the number of pieces. So if you would like to make this head from including a welding line like this, you will make it with 2 pieces. So this type of head will include welding line, so you have 2 pieces here on this head. Or if you would like to make it more than 1 piece like this from segments and mid piece like that, so you can select this configuration for the ellipsoidal head and define it like that way. Now let's add a shell course. So we add can 1. Okay, and from can 1, you can figure that we have more than 10 types of shell types. The first type is head or shell without any welding lines, shell with a welding line like this, shell to hemispherical head as a division 2, many different types like the shell with different pieces for bottom and shell from different pieces and thicknesses. Those types usually used for the storage tanks as we discussed, so you can define each blade length. Okay, and we can use one of those types in our case. But right now, let's select the shell type and define the inside diameter as 2.5 meters, define the thickness, the longitudinal welding line orientation for this one. So let's keep it 45. Defined the length of this shell course. So let's keep it like this. And if you would like to increase it and make it 3 meters, for example, if we click on save, SEG will tell you that the available delivered blade length is 2.4 meters. Okay, as we defined on the equipment settings. So you will need to decrease this value or increase the value of the delivered blade dimension. Now let's keep this value like this, and let's add another can, which is can 2. And in this time, we will define can 2 to be a shell from different pieces. Okay, and in this case, we will define each blade length separately. So in can 2, we will define the inside diameter to be 2.5 meters, the shell course length. The thickness is 20 millimeters, and from here, let's define the first course length as 1 meter, 0.7, and the start angle 55. The second course length, let's make it 2 meters, 0.5, and let's click on update. Now automatically SEG calculate the third blade length, and here for each blade you have the start and the end angle and the mid angle for each blade either. Now let's click on save. Now if we click on start to create this equipment, you can figure that the first shell course created automatically as a 1 piece, but the second shell course will be created as a simple from pieces. The first piece here, the second and third piece, as we defined on the in our model. You can figure that the building line here on for the first shell is a little bit near to that one, so we can change it. So let's come back to CAN 1 again, and from here let's change the longitudinal building line to be on 25 degrees. Click Save and update your model. So the longitudinal building line orientation, change it to be at 25 degrees. Now let's add another CAN. So from here, let's select the equipment, and from here let's add CAN 3. And in this case, we will select this checkbox, which is same as, and select CAN 1. That means during the importing CAN 3, it will be an instance from CAN 1, the same dimensions. And if you would like to make it dependent, you will select this checkbox. Dependent means if you make any change in CAN 1, it will be reflected in CAN 3. But we don't like to make that, so we will make a copy only. So like that. So if you select the CAN 3, the same dimensions of CAN 1 here, and we will keep all dimensions as they are. And after that, we will create another head, which is the right head. Okay, and the same we will do. We will make this head looks like the left head, and when we click Add, if we select the right head, you can figure that we need to make an option to flip the direction of the head, because if we open this the 3D model here, the direction of this head, the convection side goes to the left side, so the other head will be the same. So how to flip the direction of this head? By selecting this checkbox, which is flipped, this will give you the ability to flip the direction of the head. So we will select it. Click Save. Now let's click Start to start creating the third CAN and the last or the right ellipsoidal head. Okay, by that way, we have this tilted bezel with a certain angle, and now let's add a support saddles. So from here we will select the elements, and you can figure that we have many different type of supports. When you select a parent element, let's discuss this point in detail. Here, when you select the equipment itself, you will be able to add main elements like shell, head, cone, flange, gap between elements, standard fittings, gaskets, expansion joints, a lot of elements like here for API elements. Those are the main elements, which you can add attachments to them. When you select a parent element that you create like a shell, automatically you will find the attachments that you have the ability to add it to this parent element. Here on the supports tab, you will find a saddle, tilted saddle, stacked saddle, legs, lugs, skirt, anchor chair, many different of supports. In the nozzles or the opening tab, you will find nozzles with external projection, nozzles with external and internal projection, couplings, clean outdoors, nozzles according to the API, weld outlet, stud outlet, coupling nozzle, lifting lugs, so many different of lifting lugs, external attachments like nameplates, external reinforced pads, ground lug, fireproofing, stiffening rings, clips, platform supports, spiral ring. For the internal, the same, you will find a lot of data like impingement, baffle, deflectors, stiffening rings, trays, pipe supports, clad, vortex breaker, and more. So now we need to add a tilted saddle for this one. So it's left saddle. Okay, and from the left saddle, we will select the suitable type for the left saddle, and let's define the dimensions of this saddle. So let's define the height as 1.8 meters, define the thickness to be 20 millimeters, add a wear blade, define the contact angle like that, define the width of the wear blade, define the thickness, let's make the fillet as 50 millimeters, define the base blade dimensions, length and width. Here the thickness and the whole diameter. Let's make it 50 millimeters for the whole diameter, and the offset from the short edge, let's make it like that, and for the long edge, let's make it 75. And let's add second row of holes. Define the location of this saddle, and from the orientation of the saddle, so you can rotate the change the orientation of the saddle if you have a hinged saddle. So you can make it 0 degree as a hanging saddle. And from here, extra length of a straight flange, which is the straight flange of the head, we can find it here, and the tilted angle as 1 degree. And from here, from this option, if you select it, which is straight sides, the saddle will be with straight sides, like as we discussed here. So if you select this checkbox here, the saddle will be with straight edges, like the first time here. So if you would like to control the bottom width of the saddle, we will remove this checkbox and define the bottom width, and let's make it little bit than the base plate length. So let's make it 1.9 m, and let's define the outer rib width. So let's make it 300 millimeters, 300, the thickness. And let's add a midrib to this one, and add another intermediate rib, and make the spacing between them with 1 meter. Okay, and let's click on save. Now let's create the saddle. Here automatically SEG will create a new part and create a sketch, make extrude for the as the dimensions defined on SEG. After that, create the second type by the same way, create a new type, making a sketch, all of that. And you can imagine how much time you will take if you will make that by hand instead of making it automatically. Here the assembly created and assembled automatically for the saddle parts. And here we have the final part, which is the rear plate. Will be assembled, and after that will be closed and assembled with the final assembly of the equipment, like that. Okay, now let's add the other saddle. And from SEG we will select the same can, and from here we will select tilted saddle and add right saddle. And in this case we will make it same as left saddle. We need the same dimensions but on another location. Okay, so we will change the location and make this saddle as a sliding with a sliding rules. So from here we will select same as saddle 1, and from here let's click add. And when you select the right saddle, you can figure that the same dimensions are here. We will need to change the location. Let's make it 5 meters 0.2, and we will need to make this holes with a sliding hole. So this option for sliding holes, we will select it. So from here select sliding and define the sliding hole length and click on save. Now if we click on start assembly, SEG will start creating the second saddle. Okay, now we have this second saddle with the sliding rules. Okay, and we may need to change the location of this saddle a little bit. So if we have, let's check the dimensions. So we have 3 courses with that length. If we decrease, if we decrease the first saddle location, so the second saddle should be at 6 meters point 7. So we can change it. So like that. That's the second location of the saddle. And now let's add another nozzle. So let's make the modification with the nozzle. So now you can figure that the red color on this saddle, that means this saddle needs to be updated. Now let's add a nozzle. So from elements, let's add a nozzle. So let's add N1. And from here, for the N1, you can select the between different type of nozzles. As we discussed, we have more than 23 types of nozzles. The nozzle from pipe, nozzle from plate, long weld neck, self-reinforcement, long weld neck. So let's select a nozzle from pipe, and from here let's select the size as 10 inches. And from here the scalable, let's make it 80. And let's keep the location as it is right now. Let's add a rebad, define the width of the rebad, define the thickness of the rebad, define the surface of this nozzle as gas inlet, for example. And from here, we will not make it a radial. Let's make it a tilted nozzle because we need to make this nozzle with a flat flange face as a horizontal flat flange. If we make it radial, it will take the same slope of the vessel. So we will increase the tilted angle here of the nozzle with 1 degree, which is the same tilted angle of the equipment. Okay, and let's click on save. Now let's select the external connection of this nozzle, and let's add a flange. So N1 flange. And from this flange, let's select the suitable type for flange. You can figure that you have many different type of standard flanges. Let's select Welding neck raised face according to ASME page 15.5. Let's select the rating, the scalable, and the same the size and the same scalable. And let's click save. Now if we select the nozzle again and open the nozzle calculator. Here for the nozzle calculator, you can figure that you can define the nozzle location and projection to define it from the reference point here on the left hand side. So from here, let's define the location to be 800, and the straight flange of the head is 50 millimeters, and we will make this nozzle on 0 degree. And let's define the projection of this nozzle as 1600, and let's click calculate. Now SEG will create a sketch and make some calculation to calculate the actual projection of the pipe and the actual location of the nozzle. So here that's the location on the tilted view, and here is the horizontal offset from the reference point, which is the location that we defined from. Now let's click save, and now let's click start assembly. And before clicking on start assembly, you can figure that we make a modification on the right saddle. So the right saddle will be modified first before creating the second nozzle, which is N1. Okay, now we have the assembly for the second saddle, and now the nozzle assembly. Okay, now we have this nozzle, and you can figure that the facing of this nozzle is completely horizontal, not because if we make it as a tilted, not a radial. If we make it a radial nozzle, we will get the facing of the flange with the same inclination angle of the shell. But we select the tilted type to make the projection of this nozzle as we define. Okay, now let's add a sump on the shell and add some attachments to this sump. So let's select can 2. Okay, let's select can 1, no problem. And from here, let's add sump. So from here, let's add in our sump nozzle. And from here, let's make it as a forged hub, self-reinforcement forged hub. So let's select the suitable type for our case, this one. And let's define it with 40 inches size. And from here, let's define the thickness to be 20 millimeters instead of standard size. And from here, let's define the hub dimensions, the hub length, the hub thickness, and the bevel height. And from here, let's keep those data as they are. But from here, sorry, so we need to make self-reinforcement. Sorry, let's select this type. So here, so let's select 40 inches and make this 20. Define the hub dimensions. The bevel height, the width, let's make it 100, and the thickness, let's make it 20 millimeters. The fillets and some. And from here, we will keep the location and orientation. And from here, let's make it tilted. But in this case, we will decrease this value with 1 degree. So it will be 98 because this nozzle at the bottom, not at the top. Okay, now let's click on save. And let's define the projection of this one. So from here, we will define the location to be, let's make it for the first one. We have so around that value. So let's make the location around that value. The straight flange and the orientation will be on 190 degree. The projection of this one like that. And let's calculate. And SEG now will make a sketch and calculate the projection of this one and the location of this nozzle. Let's click on save. And now let's add a pipe to this one. So let's add a can, sump can. And from here, so we select the external connection of the sump and add a can to this sump. So from here, we will select the shell and define the inside diameter, define the thickness, define the longitudinal welding line orientation and the length of this can, and let's click save. Now let's add a sump head. So from here, let's add sump head. And from here, let's select an ellipsoidal head, define the inside diameter, the thickness, straight flange, minimum thickness after forming, and let's make it flipped to make the convex on the bottom, and let's click start to start creating the sump with the attachments. Okay, now we have this sump on the tilted vessel like that. Okay, and you can add some attachments to this sump, like if you would like to add a drain to this bottom head. So let's add a drain nozzle for this sump. So from here, let's select a nozzle. Let's add a nozzle D. And from here, let's make it as a nozzle with elbow. So from here, we can make it as a 2 inches nozzle with 160 scalable. Define the offset from the center line as 0. Drain nozzle. And click on save. Now let's add an elbow to this one. So from here, let's add the elbow. And from the elbow here, let's select the required type. Let's make it 90-degree long radius. Select the schedule. Okay, and from here, let's click on save. And let's come back to the nozzle. And from the calculator, you can calculate the projection of the nozzle from the seam line of the head. So let's make this projection as 400 millimeter and click calculate, and you can figure that SEG will make sketches and calculate the projection of the pipe. Here the projection of the pipe is 30 millimeters, so we can increase it a little bit. Let's make it like this and click calculate. And now let's click save. Let's add another pipe to this elbow. Let's add a pipe after this elbow. So from here, let's add the pipe. Okay, we will select a pipe, and from here select 2 inches, select the schedule, define the length, and finally we will add a flange. So from here select the standard flanges and the flange. Here let's select weld neck raised face, or if you would like to make it a slip-on raised face, make it 30 degrees, 2 inches, and the offset of the flange from facing off. After that, click simply. To start creating the bottom nozzle on the sump. After that, let's add a nozzle to the right and the left head. Let's add a drain nozzle on the right head and add a tilted nozzle on the left head. Let's add another platform clip to the platform support to the shell. After that, proceed with the general arrangement and bill of material for this equipment. Let's add a vortex breaker for this drain nozzle here. After that, after making the general arrangement, inshallah, we could make a small sample for the tube bundle bowling to know more how we can make something like that. Okay, so from here, let's select the right or the left head, and from here, let's add a nozzle. Let's add in 3. And from here, let's select a long weld neck nozzle. Define the rating, define the size, define the offset. Let's make it 300 from the vessel center line, and from here let's make it tilted. Okay, and you can figure that that's the angle between the horizontal and this one. So let's make it let's make this value as 60 degree, and let's add a wear plate if you would like to add a wear plate like this, and name this nozzle as water, for example, and click save. And from here, let's click start to start creating this nozzle. Okay, so you can make a nozzle with a tilted angle like this on head, and let's add a drain nozzle on the head on this area, on the other head. So from SEG, let's select the right head, and from here let's select a nozzle and add nozzle 4. Sorry. I open this app. So let's wait a second and close it. From here, let's add in 4, and let's make it as a long weld neck nozzle. Make it as 2 inches nozzle. Let's define the offset to be like that, and the orientation 90 degree, and make it tilted. So we will define the angle to be, if we make it 90 degrees, so we will make it 190 degree, and let's add a drain and click save. Now if we click on start, so we have a drain nozzle like this, and you can change the offset of this nozzle a little bit, so we can increase this value. So we have this drain nozzle like this. Let's add a vortex breaker to this nozzle. So let's select the sump head from here, and from elements we can add some internal attachments on this head, like the vortex breaker. So from here let's select vortex breaker, and let's define the offset from the center line. Let's make it 0. The orientation and the thickness, let's make it 6 millimeters. The length of this one, let's make it 150. The height, make it 50. The depth, let's make it 15 millimeters. The inner diameter, here if we make a section here on this nozzle, so let's take a section like that, and if we measure the inside diameter of tools, let's measure the inside diameter, so 42.8, so let's make it 42 inside diameter, and let's add a perpendicular plate and a cover plate, and let's make the cover plate with that diameter and thickness is 6 millimeters. Click save, and now let's click on start assembly to start creating the vortex breaker. Okay, now we have a vortex breaker inside the head like that, and if we make another section and move it a little bit like that, we can figure that we have a vortex breaker here for this nozzle. Okay, let's remove this half section, and let's check some points regarding to the bill of material of SEG. Here, if we open the SEG bill of material, you can figure that we have this list of elements. Each element takes item number, and the identical items which they have the same material, the same weight, the same description, SEG automatically will accumulate them and give them the same item number. Here we have 2 ellipsoidal heads with the same data. So SEG detects that we have a quantity has 2 ellipsoidal heads and give them the same item number. Here for the vortex breaker, for example, we have two identical items for the left hand side plates, and four identical items for ribs for the support saddle, another identical 4 ribs here for the second saddle. Here we can check the nozzle table. Here we have this nozzle table. The nozzle table includes the nozzle tag. Here we have the tags of nozzles that we define, the service of each nozzle as per our definition, the size of each nozzle, the outside diameter, the orientation, the thickness, the schedule of nozzles, the connected flange rating, the facing or the type of the flange along weld neck nozzle, socket weld, or slip-on sleeves, slip-on flange, round face flange, and if you have a blind, automatically the blind flange information will be filled here. Internal and external projection for each nozzle. If you have an reinforced bad, the bad information like bad thickness and the width, the welding style, and the welding information. As you can figure, we didn't define the welding information. So if we come back to one of those nozzles and open the set weld, here you can figure that you have the ability to define the welding information for this nozzle. Like if you have a single V like that, or a double V, if you select double V, you can figure that you have a double V configuration for the welding between the nozzle and the parent element. And if you would like to add a clad, so here no clad, so if you would like to add a clad for the parent element only and weld overlay here on the nozzle, if the material of the nozzle is stainless steel material, or no need for clad for the nozzle material, and if you will make a clad on the parent element and the nozzle, so you can select the third shape. In our case, no clad and it's a single V, and from here we will define the A dimensions, which is the fillet between the nozzle and the rebad. So let's make it 14, and the fillet between the rebad and the parent element, so let's make it 10 for example, and let's click on save. Now if we open the nozzle table and check the nozzle 3, which is the modified nozzle, you can figure automatically the weld style of the nozzle is changing, and the dimensions of the weld automatically change here on the nozzle table. Okay, another data like the flange table, gasket table, if we have gaskets, it will appear here. The fitting table, if we have fitting, we have only one fitting, which is this elbow. And if we have a coupling, there is a table for couplings or nozzle load. If we have a nozzle including loads, like for example, let's select nozzle info, and from here let's add some loads like that, and 4 moments. And if we open the nozzle load, automatically you can figure that the nozzle load table appear here for nozzle info and the forces and moments that you added here. Okay, let's start creating another important point, which is the update item number. Okay, by clicking on this button, automatically SEG will send the item number, which is calculated on SEG material, bill of material, to each element. Okay, this process gives you the ability to add a balloon for elements, and those balloons will reflect the item number on the bill of material, and we will check that on the drawing after finishing this process. It may take 1 or 2 minutes to finish this, and when it finished, the color of this button will be converted to the green color, and those buttons will be activated again to the blue color and red color for stop. Okay, so here it's done, and now the information sent to disk inventor items. And here to understand this point, here for example, for the seamless pipe, this pipe, which is related to pipe D, here it takes the item number 8. So when you create a balloon for this element on the drawing, this item number will be reflected to the drawing. Okay, now let's start creating our general arrangement drawing for this equipment. So from here, let's select the equipment itself, and from drawings, let's create a drawing. Select the size of the drawing, and automatically you configure that the height and width of the standard drawing. And if you would like to define a custom size or another English based standard drawings, you can select from here. You can change the location of the title block. Okay, change the orientation of your drawing, landscape or portrait. And from the active views, you can define the elevation view and select other views if you would like to add right or left view. So we will select right view and define the spacing between them. And from the orientation view, we will select the elevation orientation. That means we have a main view here, which is the elevation view, and we need to know which side we would like to look at it to make as elevation view. If we open the 3D model of this vessel, and you configure that if you would like to make this view as the elevation view, here you need to select this as the left view. So the left view will be the elevation view. Okay, or if you would like to make this view as the elevation view, you will select the back view. So from here, let's select the left view, and from here you can define the style of lines. If you would like to make the hidden lines visible, you will select this style, and if you would like the hidden lines removed, that means the visible lines only will be appear, you will select this type. And if you would like to make the element shaded with colors, like the 3D model here, so the colors here will appear on your drawing, so you will select this checkbox. From here, we will define the location of the views, and let's keep it with 30 at the beginning. After that, we can modify it to make it make sense after creating the drawing. Here we have the scale of the equipment, and here from tables, let's add the bill of material table. Let's make it appear on our drawing, and the design data table, the nozzle table, and maximum allowable working load nozzle table. So those tables will be exported to our drawing. And from notes, you can open the notes form. And if you would like to add a note, for example, just write your node and click on add. Okay, so let's add it. So we have this node here. If you would like to modify, just edit like that and click add. Or if you would like to delete, select it and click on delete. Okay, for example, if we need to make a modification on this node, those are some standard nodes. If you would like to import your nodes, just you can import it from the an external Excel sheet to here. Another option for the welding details here, we have the standard welding detail for SEG. It's a huge library for welding details. You can select from it, and if you would like to import your standard welding details to the Inventor drawing, you can do it easily. But let's select right now from our library. From here, let's select the circumference configuration of the welding line and the longitudinal welding line, and the connection between flange. There are some standard connections, and let's select that one for the slip-on flange, and nozzles with rebad, nozzles with without rebad. And from here, let's select the connection of the rear blade and of the saddle with the shell, and the ribs of the saddle. Some welding details you can select between them like that, and click on save. Now, if you would like to add some client document list like mechanical data sheet, for example, and define the number of the mechanical data sheet like that. For example, you can add, edit, and modify like the general notes. The same for vessel document list, like we would like to add a mechanical calculation. mechanical calculation report. And from here, let's add like that. So you can import and edit and modify what would you like. So it's a table, external table. You can a table you can add it to your model. For example, if you would like to make an edit and add here, for example, ref 2 and click add. So you can modify this table as per your requirement. From here, let's add the title block, the revision table. Sorry. So from here, let's define the drawing name. And the drawing number. And from here, the revision table. So from edit, it's revision 0. Okay. Like that, and click on save. Let's add another empty rows like that. And from the design style, here, if you have a huge information in your drawing and you would like to separate some tables on another sheet, that means your main sheet or the general arrangement will include more than one sheet. The first sheet, for example, you will add the general arrangement views and design data table. On the other, on the next sheet, you will add the bill of material, okay, because you have a huge bill of material, for example. On the third sheet, you will add the nozzle table, the notes, the other tables, for example. Yeah. So you can do that easily from the design style. So you can select the number of sheets. So single sheet, 2 sheets, 3 sheets, and you can separate the document to the sheets that you would like to add. And click on save. Now, if we click on create, automatically SEG will start creating the drawing, modify the size of the drawing, and the visual views. Automatically add the revision table, the bill of material table. As you can figure, it's modified and updated automatically, and takes the right place on the drawing. The design data table. After that, the notes, the nozzle table, maximum allowable nozzle load table, the client document list, and the visual document list. After that, the welding details will be done. As you configure the location of the vessel and the scale, we need to make some modifications on it to make it make sense, no clashes with the views. So we can move it a little bit to the right side, the left side, minimize the scale a little bit. So we will increase the value of from 1 to 20. Let's make it 1 to 24, for example, and move the view to the left side and the bottom side a little bit. Okay, now the welding details are done. So let's come back here, and from the drawing setting, let's open the drawing setting, and you can figure that all information that you select is stored. From here, let's minimize the location of the X direction a little bit, and the same for the vertical direction, and minimize the scale. And let's click on create drawing to update the location and of the vessel. Now it's a little bit makes sense, and now you can add your dimensions to the drawing and the balance. Okay, for example, let's add the center line here for the main shell. Okay, let's add a tan line here for the left head, another tan line for the bottom head here, another tan line there, okay. Let's add center line for nozzles, saddles, Okay, and now let's add a reference point here. Okay. Okay, now let's measure the location of this nozzle. So that's the locations that we defined from the reference point and the projection of this nozzle. Here we have the projection that we defined and the offset. But if we so the inclination value will be different. So SEG give you the tool that gives you the ability to calculate the correct value for the tilted vessels. So it's a new tool we added from months ago to give the our customers the ability to make that easily instead of manual calculation to calculate that. That's the location of this one. And here we have the spacing between the saddles. And if we take a look to this nozzle, it's not a flat end here, because if we come back here and check the tilted angle, so this value we need to make it like that. So it's like that. So we have 1 degree. We need to decrease it from that value, and let's click the assumption. Now it's perpendicular to the horizontal line. Now if we come back to the drawing, you can figure that it's horizontal now. Okay, now let's add some annotations for the nozzles. Let's add some nozzle tags. So if we select this nozzle, for example, here we select the flange. Let's click OK, and sorry, select the nozzle. Okay, now let's select the nozzle itself instead of flange. Now we have N1, so let's remove the N1 balloon. So that's nozzle N1. And if we add a tag for this nozzle, so let's select it here. So it is nozzle N3, and let's add a tag for this nozzle. So it will appear as per your definition on the SEG tree. Here we have nozzle N3, nozzle N1, N4. So the definitions that you defined it here will appear on your drawings here. Okay, now let's add the balance, the nozzle bill of material balance. So if we select this item, for example, it's item number 1. Let's select this outside rib, for example, it's item number 27. And let's make a quick check. Here for item number 1, if we open the bill of material of SEG, item number 1 is an ellipsoidal head. And here that's the technical characteristics or the detailed description of this element, which is an ellipsoidal head 2x1 with inside diameter 2 meters 0.5, nominal thickness 20 millimeters, minimum thickness after forming 18 millimeters with a straight flange 50 millimeters. And here the selected material and weight for both ellipsoidal heads. We have quantity 2, so that's the weight of both heads. Okay, so if we select the balloon again and select this head, it should have balloon item number 1. Now let's check item number 27. So let's come back here to the balloon item number 27. We have 2 elements from it. It's rib plate, sorry, and here we have the length of this plate, width and thickness, material and weight for the elements. Okay, and if you would like to add some dimensions as per your requirements, here SEG will help you to make up to this step everything automatically, like exporting tables, welding details, and give you the ability to modify locations, orientations, thicknesses, all of that automatically. Make a reflector for the nozzle balloon and bill of material balanced to your drawing. After that, if you would like to add some dimensions, it will not take the time from you. If you can add it in 10 minutes, 15 minutes, you can add all of the dimensions that require. Here, for example, if you will find some standard blocks by SEG, you can use them. For example, here let's add the nozzle load on shell. So we have here the maximum allowable nozzle load. So you can import this detail for maximum allowable nozzle load on shell. For example, you can add it like this, or on head. If you have a nozzle head, you can add it like that. If you have a plan view for this one, let's add a plan view for this one as a key plan. So we can define it as a key plan. Define the scale. Okay, and let's break the relation and let's move it here. Okay, and put that one like that. And that's the key plan. You can add a north direction like that to the key plan, and you can add the tag of the saddle. That's the left saddle, for example, the right saddle, like that. If you would like to add tag for nozzles, or the key plan, you can add it like that. You can move north direction from here to there, for example, like that. So you can make your modification easily because SEG give you all data automatically, and you can complete from it. For example, if you would like to add a detail for this forged hub, so if we open this forged hub, for example, and come back to the drawing, if you would like to add a detail for this forged hub here, if we take a look from the open that one as a custom view and take a look to that one from here, and let's move it outside here, change the scale like that. You can make a quarter section or complete section on this one. So if we make a section from here to there, for example, move it here, so we have a section like that for that one. And if you would like to make a quarter section like that one here, let's make a quarter section like that. Okay, and from here we will make it aligned to be like that. So many options you can do it if we make a break. So let's take this view to be able to move it anywhere. So let's move it like that. So you can add the dimensions of the on this hub like that, the thickness, the hub height, the hub length, the bevel height, all of that. Define the radiuses here and modify it from the 3D model. So many different options you can make it if you would like to make a separate detail like this. By the way, you can make a detailed drawing for an element or for a group, and you can check that from our channel here. You will find a lot of videos regarding to many things like creating a kettle type or AES or AGS exchanger type, live demos for towers and pressure vessels. Many things you can go through it, live webinars by image graphics. Many things here you can check it on our YouTube channel if you would like to know more about creating those things. But let's make something quick, like making a saddle. So from here, for example, let's create a drawing for the saddle in a quick view. So from here, let's make it on A3 drawing, create an elevation view and a side view. And from here, let's make it as a back view to be the elevation view. Define the locations, orientations. Okay, let's add bill of material only. Okay, saddle detail, for example, to show you how you can make something like that. And you can make a separate sheets to create some items on a separate sheets on the same drawing of the saddle, and you can check that from our YouTube channel. But now let's click create a drawing for the saddle. Here we have this saddle with the bill of material of the saddle, and now you can change the location of the saddle from here as we discussed. So we can move this view a little bit here. So let's make it on 14, and let's make that one 16. Make the gap in between them as 4. Increase the scale a little bit. So let's make it 18 and click create. Like that. And if you would like to move the view manually, you can move it manually like this. Take a section here. So we can take a section for the base view to make a detail like this, and add your center lines by that way, like that, and define the spacing between holes. Something like that if you would like to define the thickness. Okay, so here to there, so let's measure this. Add a welding sample, like if you would like to add a welding sample, like that. Okay, add something else. Okay, now let's create a new project to make the tube bundle. Okay, and in this tube bundle, let's make, so from here, let's create a new project. Okay, any questions before going to the next step, which is the tube bundle?
So everyone, hope this webinar is very much informative. And if you have any questions, just let us know. I guess it's almost like 1 p.m. So just let us know if we can continue with the exchanger modeling or not, so that we can show you how we can do the two bundle modeling and all exchanger modeling.
Yeah, Rajesh, Mr. Ahmed, thank you very much for your detailed presentation. I really appreciate you taking time out and explaining all these things actually. I have few questions which I would like to discuss before you go into tube bundle. First thing, is there any way you can get automatic dimensioning?
Okay, there is an SEG and automatic dimension way, but we don't recommend it. I will give you an example for this. For example, if we create a drawing for it, so let's select this head and create a drawing for it. And from here, let's select the two views and make it from the back view, and from tables, you can select the dimensions from here. Okay, and from here you can select the type of dimension as a linear or 2-point dimension, something like that. And let's create right now like this. You can figure that you will add some dimensions to the element. Let's create it for the second saddle, for example. Let's go to the details. Here, for example, open the second saddle, and from here, let's create a drawing. And let's select the back view, and let's add another right view. And from here, find this here. Okay, so from tables, let's select dimension and add point dimension, point to point dimension. And from here, let's select the subsheets, scan component. And now let's add a detail for the base plate. So let's select base plate, and let's take a look from the top view. And here dimension, let's point to point dimension, and for the saddle, let's make it from the back view, and let's add point to point dimension through dimension, and let's click on create. Here we have this saddle. As you can figure, you can add some dimensions to the views. So we don't recommend this because it will give you a huge number of dimensions, and you will need the time to delete not required dimensions. Okay.
Okay, understood. Okay. My second question is.
So it's optional, but we don't recommend it for that. It is better to add the required dimensions by you instead of making, because SEG will make the dimensions as per your selection here for the point or linear dimension. So will select the dimensions. Any other questions?
Yeah. We generally do. I think I will ask our team to show you one drawing. Like we do vertical tanks with horizontal tanks. I understood the configuration. In our configuration, we have a bottom dish and we have a shell for the vertical tank. In top, we do top flat. Actually, we do atmospheric tanks. It will be a flat top and with a bolted connection. That kind of drawings, how we will generate, I wanted to understand. If you want, I can show you, our team can show you the drawings or sample.
Okay, if you send it to us, I could tell you if those items are included in SE and you can do it or not. And by the way, if something not included, our development team offers to make that for free for our customers. So if you send it to us, we did a lot of things like that. Our customers asked us to add some items they usually used them, like as we said here, for example, for the saddles. This type, which is saddle with lifting bar, we created based on one of our clients' requirement on they are a heat exchanger manufacturer, and they usually use this type, and they ask us to add that. So if you have any required items or elements, you can send it to us, and we can cover it, inshallah.
Yeah, I think we can show it now itself. One small example. Maybe you don't need to do it. You can just verify it whether it is inbuilt or not. If you can give us the option of screen sharing, Vadivel, can you share one document to them?
Okay, Fauzan, would you mind to make?
Yeah, just a minute. You want me to make?
Mr. Vadivel, can you give this? Give it to Mr. Vadivel control. Vadivel, can you show one drawing?
I'm making him as a presenter.
Vadivel, open vertical tank, flat top, and bolting connection and welding connection. That drawing.
I had opened already. Can I zoom?
Can you give the control to Mr. Arun? He already opened the document. Arun Kumar. Hello.
Excuse me, what?
I think there is some server issue. Can you give control to Mr. Arun Kumar? He will open the.
Yeah, I'll make Arun Kumar as the presenter so that he will share his screen.
Yeah.
Yeah. Arun, can you share?
Can you see my screen now?
Yes.
So this is one of our typical vertical tank with the bottom distant and top flat. So here we have welded type top cover, but however, so in some cases we will have bolted type also.
So the thing is, you will have a angle welded to the shell, and there is a flat top at the bottom. That is around 10 mm thickness flat. Can you show the detail, Arun? This one, like this. One angle will be welded to shell, and on top of it, plate will be there. Sometimes it will be welded, sometimes it will be bolted. Hello.
Also,
Mr.
runs inside ladder. That also we need to check whether we can do it in this inside ladder.
Okay, regarding detail like this, something like this is included in SEG. If you would like to add a compression ring, which is this angle, and if you would like to add a flat plate, there is a type on SEG for blades on flat blades on head. Or if you would like to add it as a flange, if you have a bolted flange, so you can add a blind flange as a blade with bolts, so you can make a detailed connection like this. And we can make something quick for regarding to this. Fawzan, kindly give me the.
Yeah, Ahmed, would you like to say something?
Yes, I would like to make a quick sample for this connection here.
We'll make you a presenter.
Inside this top plate we have support plates, flat plates for the bracing. If you talk for
Okay, let's open a new project.
It's okay. You can show this angle and flat plate, and that blind have some internal ribs. So in some cases,
January 2022, and select the location of the project. And from here, let's select vertical Z, for example. And from here, let's click on finish. Now the current project will be closed, so it takes minutes to close this project. After that, SEG will create a new project. Now we have this new project, so let's add a shell. Okay, let's define the shell inside the emitter. For example, let's make it 2 meters, for example, and the thickness 10 millimeters. Okay, the length is okay, and let's add a support plate for this shell. Next. From here, let's select this as UVN and select the size, and like this, let's add a wear plate. The width, which is dimension C, and the thickness, the fillet value, the offset from the end. Let's add top cover. Let's add a base plate, so the base plate length, the dimension. So let's make it like this, and the length, make it like this. The thickness 20, the offset of 2, OCD. Okay, 25 as the whole diameter. The number of holes. We have 4 support legs, and let's click on save. Now let's add a compression ring. So from here, okay, so we need to change the type of the project. So let's okay, so let's save this project or close this project. Because I select the wrong module from the beginning. I should select the overall module, but okay, let's click on exit. Okay, now let's open SEG again. And let's open the project, which is on the desktop, the new tool. And let's change the type of the project. Let's make it overall and make it change. And from here, if we select the shell, and for the equipment and from elements, we can add a compression ring. So let's add a compression ring. And from here, let's select the suitable shape. So let's define this as meters 20 offset, the size of the flange, and let's click save. Now if we select the equipment setting and make a preview for elements during creation and click on start. The support leg. Okay, we need to define the location, the right location of the leg. Okay, now we have the compression ring here, and you can add a blade or flat blade here if we select this one, and from heads you can select flat head. So this type of head without bolted flanges. So if you select it, we can select a circular flat end like this, define the inside diameter like that, or like that. We define the thickness, and from here let's select star and let's read the assembly. So we have this flat head, and now let's add some internal cross beams. So from the view, let's make section like that. Okay, and from here let's add some cross beams. So let's select the shell, and from here let's select internal, and from the internal let's add a cross support beam. For example, so we have this. You can select the suitable type of the cross beams that you would like to add it. So let's select, for example, the ASIC type. So let's define it like this: the location and the orientation. So let's keep the default values. After that, we can modify it to suit the our requirements. And let's click on assembly. So we have the cross beam here, so we need to rotate it 190 degrees. So let's make it at 0, for example, or like that. Click save and run. So by that way you can add the bracing like that for the compression rings by that way, and we need to increase the location by 10 millimeters here. And by the same way, you can add another stiffening beams inside the shell to be welded to the head like that. And if you would like to add a blind flange, we select the shell, for example, and from the select the vessel, and from elements you can select a blind flange. And from here, from the blind flange itself, you can select the blind type as user defined, and select the required type as a flange without raised face, or a flange with a raised face, or double raised face. Select the required dimensions. For example, let's define the outside diameter, the thickness as a 20 millimeters, the bolt circle diameter, like that. We have, for example, 48 bolts, 30 millimeters, and we have 62 holes, for example. And let's make it flipped and click save. Now if we click assemble, you can make a blind flange with holes connected over that one. Okay, so if we delete the flathead, you can figure that the blind flange will be directed correctly here. So if we, for example, if we delete this one like that and click on start assembly, you can figure that the blind hole connected to this one, and you can add nozzles to this blind flange, by the way. So from here, let's add in one, for example, and from here, let's select as a nozzle from pipe, define the outside diameter of the pipe, the welding line, the offset from the vessel center line, the orientation, and let's add a wear plate, and let's click on save. Now let's add a flange, so M1 flange, and let's make it a slip-on flange, so it's 24 inches, this 15 millimeters, and let's start creating the nozzle as a nozzle from pipe, not from nozzle from blade, not from pipe. Okay, so we need to flip the direction of the blind flange. So from here, we can select the blind direction and remove the flip.
Here one question. That flange, we are considering the standard flange, right? Some places in manway, we take normal plate. Instead of standard flange, we consider as a 10 mm plate or 16 mm plate. Basically, in case of manway, instead of going for 16.5 flange, actually. That can be done. Is it possible?
Would you mind to say your question again, because I cannot hear you?
Yeah, for the nozzles, okay, example 24-inch manway nozzle. Normally we use standard 24-inch flange and the blind flange. Right? Instead of standard flanges, we use customized plates. For the flange, instead of 16.5, we used 16 mm plate which is welded to the manway neck. And that blind flange also, we take it as a 20 mm standard normal plate instead of standard in some cases where atmospheric pressure is there. User-defined API
gives you the ability to add some standard flanges. Here you have the standard flanges. So if you would like to design the flange or define the flange as per your request, from the design flange, for example, And if you open it, you will find a huge number of types of design flanges. So you can select the suitable type for your case. For example, it's a loose ring like this, or a loose ring with wrist face. So this type is a flange. If you take a look to the image on the right hand side, I think this type covers your requirements, which is a flange from a blade without any wrist face or.
Yes, correct. This is the one which you are looking for. Understood.
So you will find many types of configurations. You can select the suitable type which give you the ability to cover your requirements depending on your case.
Yes. Sorry for asking too many questions. Actually, you put that top plate as with the bolting, correct? Now below it is connecting to the angle. In the angle, how we can add holes for the which is connecting to the blind flange? Can you go to the model one time? I will tell you the question. I will repeat my question. You have a top flat, right? A top connection as a flat with the bolting connection, which we have given, and which is directly sitting on the angle, which we have given outside the shell. So we need to bolt it. This bolting holes we have to give it in the angle. Is that possible? Because you have considered as a compression ring, maybe you have to consider as a ring.
Okay. If you have a flange, if you have designed a flange here, you will get the bolts directly. But if you would like to create a bolt hole here, you can make, for example, if we make a sketch here, make a project for this hole. Okay, for example, let's add a bolt here. Finish sketch. You can make a hole like that because the compression ring not include, usually it's not include a hole. So let's find the hole diameter. So it's a straight hole. Define the diameter like that, and let's make a circular pattern for this one. So it will be on the y direction.
You understand our requirement. Now I understood you are doing in a solid, correct? Yeah. Instead of compression ring, can we add it as a non-standard design flange with angle in it? Is it possible? Because now we are giving a flat ring. Instead of in that place, can we add a angle also as one option for the body flange? Is that possible?
As mentioned, from minutes, I just tell you how to add design the flange here, how you can add it.
Yeah. You should be understood.
You would like to add it on the real model? Okay. Okay. So let's delete this nozzle here.
In the designed flange, I wanted to add. Sorry for asking too many things actually, and you don't need to do again this bundle review. I just wanted to clarify. This is what we're majorly working on. That's why I'm asking this question.
Again, please, because I cannot hear you.
What I was saying, sorry for asking too many questions. You don't need to do any bundle design. We are majorly working on this design. If we clarify these points, it would be better for us. That's what. Instead of in the loose ring, what you are adding, instead of flat plate, can we add as an angle so that it will automatically take the bolting connection when we add the blinds?
I will do it for you. One minute. So we need to Now we need to move the flange before the blind flange. So for move, let's make it move before blind flange. So the arrangement will be the flange, designed flange will be connected to the shell. After that, the blind flange will be connected to the flange. And let's create this. After that, we will add a bolted stud bolt to the created flanges. So no need for this cross beam. Okay, now let's add stud bolt. So from here, let's select the blind flange, and from here, let's select stud bolt. And from here, select the type ISO or UNC and select the size. Let's measure the knot spacing from here to there. We need 40 millimeters. So the spacing will be 40 millimeters, and let's make the length of the stud like that and click on start. Okay, now we have, is that cover your question right now?
Actually, partially, yes. Well, what I was trying to say, can you zoom into the ring flange what you added below the line? That
I don't understand your question exactly. I don't understand what you would like to say.
Okay. What I was trying to say earlier, we had a compression ring, right?
Yes.
Yeah. Then you were trying to add the bolting as in to the solid, correct? In the inverter. Now, if we add it as a ring flange.
The first case, we had compression ring and a flat plate welded to it. Okay. After that, you asked me to add a plate with bolts instead of flat plate. Okay. After adding it, we need to make a holes on the compression ring. Is that right? So
yes,
adding
yes.
the compression ring, we should make it manual. Because the compression ring, no compression ring is included on bolts. So, but if you request to make this on the compression ring, so our development team can do that. So it's a request. You know what I would like to say? It's not included on the features right now. Rolling on the compression ring. But if you would like to add a feature like this, the compression ring, our development team can do that.
Okay, fine.
After that, you asked me to add a design flange as a flange from place and make a bolting connection with the bolted cover. And we did like that. Are you asking for something else?
Yeah, the same thing only I am asking. What we do is the same connection details, our team will send it to you. You can check on it, how it can be automated. As I said, you will check with your development team also. This is what actually basically required. I think we got most of the part.
Because I didn't receive anything. Did you forward it 2000?
Can you repeat again?
Did you forward this drawing or this detail 2000? Because I didn't receive anything.
I think we have sent one detailed drawing to image graphics personnel. No problem. We can send it to you one more time again.
May 1000 received it, but until now I didn't receive anything. I will ask him.
No problem. We can send it to you also. No issues. You can check with your development team on that. And second thing, to take things forward, can we install any trial version in our office so that we can try with our configuration one time? And you see, if things works out, we can buy one license.
Available as a trial version for 15 days. If you install it automatically, you will get a 15 days trial period. So kindly contact Fawzan for more information about the download link and the installation steps. And if you have any, if you would like to get any support, kindly contact us, and inshallah our development team will cover your issues.
Okay, fine. Thanks, Ahmed. You given very good. You have taken too much time of your, and you have given a very good.
My pleasure. And thanks a lot for all of you valuable time and give us the opportunity to present our solution for modeling.
I will ask my team if they have any questions.
I should go off 2 minutes because I have another meeting. So, for the tube bundle arrangement, right now I just have 10 is than that for this meeting. So, if you have any questions, we can discuss it.
Ahmed, just a small doubt in my. Generally we are using our CADWorks system. What will be the interface between the CADWorks and SEG here?
Actually, no integration between SEG and BricsCAD or CADWorks.
We need to.
As we discussed in our presentation, we can read the exported access database file from BDLit. We can read the exported CSV file from the HTRI. And soon, inshallah, with the next release, which shall be released in next April, inshallah, it will available to read the exported XML file from Compress.
Okay, now you can import from PVLite, right?
The access database file from PVL.
So once we've taken the database file, it will do the automatic modeling. Can you show any example how it will import?
We already presented you for.
Excuse me, gentlemen. I'm sorry, Jagdish here. I would like to firstly congratulate.
I will present as a video, and if you would like to.
I would just 2 minutes, Ahmed. I would like to congratulate you firstly for bringing such a tool in the field of these pressure vessels and static equipment, basically, more or less out of any other CAD working softwares or modeling softwares. We thank you for your valuable time, and we thank you how you have presented with patience and with all the knowledge you have expressed. However, we have a few queries that we cannot be immediately put for that much time for now, because we also have a few tasks that we have to be accomplishing today. So we will be forming the queries and we'll be in communication with either Devender or Mr. Fawzan. So we may be mutually be communicating viably. Okay? Okay. Thanks to all the gents and thanks to everybody for the cooperatively being part. And we will be taking leave from amateur engineering for now, and we will be mutually be coordinating with either Devender or Fawzan. Thank you so much.
Okay.
Bye.
Thank you so much.
Thank you,
for your
gentlemen.
valuable-
Thank
Have
you
a
for
nice
the
day.
participation.
Have a
Thank you.
nice day.
Bye.
Bye bye. Salam alaikum.
Bye. Have a great day. Bye.
Thank you all.